Hey guys, welcome back to my channel. It's been a minute. I hope everyone is doing well and staying healthy. Happy spring. I've been pretty busy with a bunch of work and family and traveling, and I got this new chair. It creaks. I feel like it's making creak noise. Okay, it's fine. I just won't lean back. I won't do that. But new chair. I don't know if you guys even could see the last chair that I was sitting in, but I'm pretty excited about this purchase. So we'll see how it goes. I've been wanting to make this video for a while, so enough of the chit chat and let's get into it. So I'm sure you guys have heard all about the James Webb Telescope. It's basically been blowing up all the science, social media, well, kind of all the social media really, ever since last Christmas. So maybe you guys have already clicked on the links and know all the things, but in case you haven't, this video is answering the question why the James Webb Space Telescope is such a big deal. Well, to start with, it is the largest and most powerful telescope ever to be launched into space. It cost about $10 billion to build, took about 20 years, and similarly to the International Space Station, it was the collaboration between several space agencies, this time including NASA, the European Space Agency, and the Canadian Space Agency. It's about 3 stories high, roughly the size of a tennis court, and despite being only a little bigger than its precursor, the Hubble telescope, James Webb is about 100 times more powerful than Hubble. But what exactly does more powerful mean? Well, to start with, the mirror on Webb is 3 times larger than the mirror on Hubble. And this matters because a larger mirror on your space telescope allows you to see fainter objects further into space. And something else that helps us see fainter objects further away is the fact that Webb has been designed to observe in infrared light. Now, the Hubble Space Telescope, which was launched in 1990, could observe objects in the visible and ultraviolet light. But as I said, the James Webb Telescope will see the universe in the infrared. So what is the difference between all of these lights, and why does seeing in the infrared matter? Basically, light travels in a range of frequencies along the electromagnetic spectrum, and our eyes have evolved to detect a certain band on this spectrum known as visible light. Ultraviolet light and infrared light are outside of our range, but the cool thing about infrared light is that it has a longer wavelength and can pass through objects in space that visible light is blocked by, like gas or dust. This is why images taken by telescopes that can detect infrared frequencies can pick out objects beyond these clouds, and the images can appear clearer than those images taken by other telescopes. Like, take this image for example. The photo on the left is a pretty famous photo taken by Hubble of the Carina Nebula in 2010 in visible light. And the photo on the right is that same nebula taken with infrared light. And suddenly, we are looking at a lot more stars. And so rather than seeing James Webb as simply Hubble's replacement or successor, it's really just seeing things differently and further away. The large gold-plated mirrors on Webb allow for more surface area to collect light, which again enables the telescope to see much, much further out into the universe. Also, about these gold-plated mirrors, anyone else getting like a Bond villain vibe off these things? But how much further into the universe can Webb see, you ask? Well, Webb can detect objects 10 billion times fainter than the faintest stars visible with no telescope, or 10 to 100 times fainter than what Hubble can observe. It basically was designed to see the first stars and galaxies that ever formed in the early universe. According to NASA, it will be able to see the universe 250 million years ago after the Big Bang. So it's sort of a time machine. Now, you might be like, what are you talking about, Marion? It's just a telescope. So for those of you who are a bit confused, I'll explain quickly. The Andromeda galaxy is the galaxy closest to our own, the Milky Way. And even though it's still millions of miles away from us, you can still see it with your naked eye, unless you live in LA, or with the help of a telescope. But when you look at Andromeda, you aren't looking at what it looks like in the present moment. It's not like looking up at the sky and seeing a bird. You're looking at what it looked like 2.2 million years ago. The reason for this is that it takes that amount of time for light to travel from Andromeda to Earth. So looking up at Andromeda is sort of like time travel. but without having to leave our planet. So the further away the galaxy, the further back in time you are seeing. GNZ11 is the furthest galaxy that has been discovered thus far as spotted by Hubble. And the light is 13.4 billion years old. So that's a lot of time travel. And being able to look so much further back in time will give scientists so much more information about how stars formed, what makes cosmic entities work, and what the universe was like 250 million years after the Big Bang. Basically, Webb will let us take a peek at the early universe. Also, Webb will orbit in a completely different place than where Hubble currently is, which is a pretty low Earth orbit. Webb will orbit a point in space known as the second Lagrange point, or L2, about 930,000 miles beyond Earth's orbit around the Sun. And for comparison, the Moon orbits about 250,000 miles from Earth. Webb will keep out of the Earth and Moon's shadow, and it's staying so far away because it's observing very faint infrared signals of very distant objects, so it needs to be shielded from any hot, bright sources, including itself. I found this interesting graphic that shows Webb's sun shield also helps separate the two sides of the craft. One side, the hot side, will run about 185 degrees Fahrenheit, and it has solar panels, communications antenna, a computer, while on the other side, the cold side, running at about negative 388 degrees Fahrenheit, holds the mirrors and science instruments. So on one side, you could almost boil water, and on the other side, you could freeze nitrogen. It'll also be studying the atmospheres of thousands of exoplanets, the habitable zones of distant stars, looking for regions that could contain the building blocks of life. And finally, in case you've been wondering, it's called the James Webb Space Telescope after James Webb, NASA's second appointed administrator who oversaw the Apollo program and basically oversaw NASA from the beginning of the Kennedy administration to the end of the Johnson administration. The James Webb Telescope was launched into space on Christmas Day 2021 from French Guiana. It reached L2 on January 24th, 2022, and it's basically in stages of operational configuration until it starts sending us photos back sometime this summer. NASA's actually got this really cool website that is tracking where Webb is in space right now and what step it is on of its configuration. I'll put a link to that in the description below in case you want to see where Webb is right now in real time, because why not? So basically, the James Webb Telescope is such a big deal because many people think that it's the most important thing that NASA has done in many years and could potentially completely change the way that we think about and see the universe. With this telescope, we'll be able to see things that we've never seen before. And when it comes to science and exploration, it doesn't really get a whole lot more exciting than that. I'll also put a link in the description below of James Webb's Twitter and Instagram handles, so in case you want to see the photos as they come out this summer, you can. Also, side note, I discovered this guy who blatantly tried to do a cash grab from NASA by creating the James Webb NASA Twitter handle, but he did it after James Webb already launched into space. Boldly uses the word ransom in his bio. Sadly, though, he was 11 years too late. I'm really hoping this is a joke. But I'm not too encouraged. Okay, that's it for the video, guys. Thank you so much for watching. I hope you enjoyed it. Please let me know in the comments below if you're excited to see James Webb's photos this summer, how you feel about my new chair, and if you think that guy is serious with his ransom Twitter handle to NASA. I have a lot of questions.